Hi, and welcome back to the electronic dice project. So today we're going to be looking at, I think it's step 5 now, where the previous step, what we added was the this decoder IC here, and we made the power supply connections and added a couple of the control pin connections, so the blanking and the store input and the reset input there, the lamp test input as well, and we just used a temporary resistor here to hold one of those input pins to logic high, so that when we go to do test it next, which was what we'll be doing in this video, we don't get weird results because of a floating input condition. Okay, so we're going to be adding a 7-segment display, and that display, you can see it's got a little decimal place at the bottom on the right there. So what we're going to be doing is we're going to be adding this into the breadboard and connecting it up to the output pins of the decoder chip there. Before we do that, I'm just going to power down my circuit so I don't accidentally damage something. And I just need to give myself a little bit of space on the right here, because this is where I want to have my, my touch switch when I add it later on. So in this project, what we're going to be using is just a single resistor. The reason why is because it makes it much easier to breadboard. However, there is a drawback, which will become apparent when we go to test this later on. So on the 7-segment display, there are 10 pins along the back, or on the display. The middle pins on these ones, anyway, on both the top and the bottom are what we call the common cathode. So they're both connected together inside, and these are the cathodes of all of the LEDs that make up the 7 segments and the decimal place. So the eight LEDs that make up this display each have their the cathodes, or the negative end of their LED pin, is connected to both of these two middle pins. Okay, and we're going to be using a 470 ohm resistor, and just connecting that from the middle pin on the bottom to our 0 volts. Okay, now I'm just going to show you how we can actually test this. So if I connect the power supply back up, just using a bit of breadboard wire, connecting it to the positive, you can see that when I touch it on that pin there, that middle segment lights up. Okay. And it's important you do this with this dropping resistor there. If you don't have a resistor, you'll damage the LED in your segment, and, well, it's pretty much going to be the end of the segment. So you can see that each one of these pins corresponds with one of the segments. Okay. And what we need to do now is line up which of the output pins on this 7-segment display driver chip matches up with each one of these segments. And so it's useful to have a pinout diagram for that. You can also use the schematic diagram that I provided with this project. Okay, so on the display, pin 1 would be the bottom left, and it just goes anti-clockwise around, just like all the other ICs. And I'm just going to connect it on the display, on this diagram. I'm just going to connect it from top to bottom. So pin 13 of the chip connects to pin 7 of the display. And I'll just use a piece of breadboard wire. So 8, 9, 10, 11, 12, 13. So 13 is right over here somewhere. Okay. So 9, 10, 11, 12, 13. And that connects to pin 7 on the display, which is this one right there. And this should be segment A, which is this top one. Okay. Now it's important not to actually test this now while it's connected to the chip, because it might damage the chip. So I might actually do, just to check to prove this, I'm just going to lift that one out. So this should be the top segment when I touch it. No, it's got to be powered up first. There we go. Yep. Okay, so that one's segment A, and that corresponds with pin 13 on the chip. So now I've kind of, I suppose I've got my bearings in that I now know that I've made that one connection correct. It makes it a bit easier now as I go around the chip to add the other connections. Okay. So that one, pin 12 goes to pin 6. Okay. Pin 11 goes to pin 4. Now pin 4 is going to be right down the bottom here. So I've had to bend my bit of breadboard wire. And pin 4 is from the left, 1, 2, 3, 4. So it's the one just to the right of the resistor there. Pin 10, that connects to pin 2. So again, it's going to be right down the bottom. And goes to pin 2 down there. Okay, nice and neat. Now pin 9 goes to pin 1. Pin 9. That's pin 1. Okay, so that's those ones along the top there. And pin 15 connects to pin 9. Okay, so here's where there's a bit of a swap going on, but that's okay. We can work with that. So pin 15 is the one that's just next to the power supply. And I think I might have got the wrong one there. Let's get the number one. 15 to pin 9. And then pin 14 connects to pin 10. So now we've made all the breadboard connections. What we can see is, well, now we can test it to see if we get a number. But the first thing we might need to do is actually put some inputs on this thing. Because at the moment, we don't have any of the number inputs on our chip here. And so what can happen is if the number that's on the binary coded decimal number that's going onto these inputs here is greater than 10, or greater than 9, so 10, 11, well theoretically you can go 10, 11, 12, 13, 14 and 15. If they are greater than 9, then it'll blank the display, and so it's not going to work. So what I'm going to do here is I'm going to actually set, using a resistor, so I'm going to connect the D1, D2, D and D4 pins to 0 volts. Okay. Now I'm using a resistor so I can do that, so that in a moment I can test it by connecting temporarily those pins to positive and see if it lights up. Okay, so pin 7, actually it starts pin 1, pin 2 and pin 7. So there's pin 1. Now it doesn't matter what value resistor you use, this is just a temporary testing measure. Okay, still not getting anything. So what's going on there? Okay. So one of the first things I'll do to test this is just to make sure that my display is getting some getting power to it. Okay, so as I got, got power there. Is it on the actual chip itself? So just putting it on the power supply pins on the chip. Yep, they're getting power. Okay. Blank and store. Oh, maybe what's happened is that we're holding this blank and the store logic high, and what that's going to do is that's going to, well, it won't blank the display, but it will store the number. And if it's stored a number that's not a proper binary coded decimal number, there we go. So now we've got 0. Okay, so you can see here when I touch it low, it blanks the display. So I'm just using a bit of breadboard wire here now. Oh, disconnected something somewhere. So when I touch it low, it blanks the display, but when I let go, it's displaying a 0. Okay, so now I'm going to have to refresh this every now and then. What I might actually do, oh, how am I going to do that? Alright, that's okay, we can do this. What I'm going to do is I'm going to one at a time hold a pin high. So this is pin 1, which is the 2s. So what I should expect to see here when I use my breadboard wire to reset it, so this is the same as what I'll be doing when I touch my finger on the button. I should see a 2 come up on this display. There we go. So that's working. I'm going to just cycle through connecting pin 1, then pin 2. I'm just doing that because that's the pin order, not because of any other order. And when I refresh it, okay, so that's obviously the 4s pin. And then when I touch it on pin 6, this should be a 1. There we go. And this works for combinations of those pins as well. So if I connect, let's say I connect pin 4 and so pin 7 at the moment is held high, and if I connect pin 1 high, so this was the 2s and this was the 1s. So now when I refresh it, I should get a 3. There we go. So we can see that this is taking the digital binary value that's on this input here. So at the moment it's a 1, and a 0, or 0, 1, 1 would be how you would say that in binary. So 0, 1, 1 corresponds to 3 in decimal. So that input is being on the input here, and then when I effectively strobe it in by touching this pin here to 0, it loads in that new number. Okay, so if I change the value on the input, so now I've changed the value on the input, notice here how it hasn't changed on the output. Okay, that's because of that store input pin, which I'm holding high. Okay, when I make it go low, which is also connected to the blanking input pin, it blanks the display, but now it's not storing the number on the output anymore. It's refreshed it with whatever the new current input is. Okay, and you can see that now it's showing that. Now what will happen in our circuit is instead of having these input pins connecting to high or low by a wire manually, what we're going to be doing is connecting it to high or low by the output conditions of these logic diodes that we set up earlier. And so so what will happen is these are going to be continually refreshed. And they're going to be cycling through in the binary equivalent of 1 through to 6 very quickly. So every time this flashes, that's a new number being put on there. And when we remove this big capacitor, that speeds right up, remember? Okay, so it's fast enough that we can't even see it flashing. Yeah. And so what's going to be happening here is that these numbers are going to be cycling through on this, and it's only when we touch our switch that those numbers get put through to the output. But we won't see that because we're blanking it. But then when we release it, it stores that and then shows it. Okay. So we've tested the display. The next step will be connecting the inputs to the display to our logic. And then the next part after that will be building our touch switch, and that'll be the last step.